Welcome to the LPLA Watershed Detective Program online training. I guess I am going to be your MC or your facilitator this evening. My name is Mac Becco. And yeah, thank you for joining us. We are using the training and experience from the Isaac Walton League to do a unique water monitoring program that goes beyond just data collection and actually investigates the sources of pollution so that action can actually be taken. So to start this fall, the end of the summer from August through hopefully October, depending on weather, we're going to be doing some water monitoring in Hay and Bullard Creeks. Both of them are trout streams that are impaired for E. coli. So we're going to have 3 different teams out there doing some water monitoring, and LPLA will be kind of providing support and facilitating those volunteer teams. So I just want to start with a reminder that this online training is serving 2 purposes, basically. One is just so everybody can become familiarized with the equipment, with the procedures, and we can all be on the same page with some logistical items. And it's also going to serve as a reference. So it's not intended to be the all-encompassing hands-on training that you will do on your first day out in the field with your crew. We do have a website up on our webpage. If you go to LakePepinLegacyAlliance.org and then you go under projects, you'll find a water monitoring page. And that gives an outline of the program, and then in the upper right-hand corner of that website, there's a button and it says training/data entry. And so if you click that, you'll go to another page and that will have all the training materials, our manual that we're still putting the last minute touches on, data sheets, videos for training, and then also a place where you can enter the data, and that will be for the volunteer leads. After they're in the field, they can go to that website and enter the data. Without further ado, I'm going to bring in Riley Main, who is going to talk about equipment, procedures, including quality control out in the field for sample collection, safety, and logistics.
So again, we're looking at Hay Creek and Bullard Creek, and we're going to have 1 team dedicated to Bullard Creek and then 2 teams split up dedicated to Hay Creek, so 1 on the upper end and 1 on the lower end. And each team will have their own set of equipment. So when you go out to your site, and I'll talk about the timing a little bit towards the end, but right now we're just going to go through the specific parameters, what we're looking for, and how to go through that process for monitoring. Every team is going to have a team lead, and they will be in charge of keeping their equipment and providing it during the sampling days. So this is an example of a sampling sheet that the Isaac Walton League used, and we'll have this online, our own version that will have a few different parameters, but basically that's what you're going to take out with you, as well as the monitoring equipment, and you'll be able to record all of your data there. So the first couple of things, you're going to record the date, the start time and end time of your monitoring sampling. Who is the team lead that day should be consistent as much as possible, but there may be some substitutions based on availability. Who are the participants helping with the monitoring that day? And then more of the details about the actual site, so weather conditions for that day and the previous few days, because we want to really pay close attention to when there has been a big rain event and how that may be affecting water quality. The water level, so is the water level high or low compared to normal conditions? And then what we'll use some equipment for is temperature, so that'll just be a thermometer taking the temperature of the water. Transparency, which we will use the Secchi tube to measure transparency, and I'll walk through that momentarily. We have a phosphorus test kit that comes in this nice little container, obviously to test phosphorus in the water. And then E. coli, and I'll pull out the E. coli in a little bit to show you what that looks like, because it's being stored in a cooler right now. And then the other things that we're going to be looking at in terms of parameters are just any visual observations. So are you seeing bank erosion close to the sampling site that we would want to note that? And then if you are able to take some photos when you're out there, that's really helpful too, because as we share this data with the public or with other agencies, it's really helpful for them to get a sense of what the conditions look like beyond just the written visual observations. And then again, another indicator is rainfall. So this will kind of be measured when you write down what the weather conditions were the first few days leading up to the sampling, and whether the water is high or low. But if we have the possibility to actually measure the amount of rainfall, that would be wonderful to have on a consistent basis as well. So those are the parameters that we're talking about. And again, this is really to just familiarize you so that when we go out in the field, if you have any questions after watching this video, you kind of know what questions to ask and you're not just starting, with a blank slate. So you're gonna start out with this Secchi tube, and the tube goes up to 95 centimeters, which is the very top line. And so to use this, there is, if I can show it, a black and white image at the very bottom. And to measure transparency, you basically look into the tube and see how far down you can go where you can still see this bottom image. So we're gonna try this simulation and we'll see how it goes, and hopefully I don't spill everywhere. But depending on where your sampling site is, and in some cases it's gonna be a public road, and so you might be taking your sample off of a bridge and having to lower a bucket of water down into the creek. So I have brought with me this bucket of water with a rope tied to it. So I would lower this down. I would lower this bucket down into the creek, collect my water sample. Again, we'll provide you with all of this, and then lift it back up with the water inside of it. Thankfully, I've already got water in here, so I don't need to do that.
And the water in both of these streams is pretty clear, so you can expect that you'll have to fill the S tube up pretty high.
Yep. Oh, all right. So now Kenzie's going to hold that tube up as I dump the rest of this water out so that I can show you the next step. I'm going to display the tube.
Display the tube. This is the tube. You can see it's very clear. It's all the way full. I can still see to the bottom. I can see that black and white disc at the bottom. So when you're out in the field, you should get to a point where you won't be able to see it at a certain level. Again, this is just tap water.
But if you can't see this black and white disc at the very bottom, then we need to take some water out. So there's a little lever at the very bottom, and if you push it into the ground, or in this case into the bucket so we don't get the carpet all wet, it will actually drain some of the water. And it drains it pretty slowly.
There you can see.
So that you can watch the water level go down. And when I get to the point when you can barely see it, that is the perfect spot to measure. So to make it a little bit more interesting, I have collected this sample of water that has some dirt in it. And I'm going to mix it up to create turbid water, which you may come across during your sampling. So now we have this muddy, turbid water with resuspended sediments in the water. And I'm going to pour this into the Secchi tube to see if it changes how much I can see. Whoop, that's really high.
And this isn't something you'll do in the field. This is just to show some actual turbidity in the S tube.
Yeah. So now it's kind of making its way down. I'm getting rid of some extra water. And now, when I look in there, I can no longer see the bottom. And oftentimes it's good to have two people look and record where they can see it, because sometimes just with, eyesight differences, it can be a little bit subjective. So you want to make sure you have two people who generally agree that this is the measurement where you can just start to see that black and white disc at the bottom. So now I'm going to keep letting water out. You can see it from the screen. Probably doesn't help when I'm talking down, but you get the idea. As soon as it gets to the point where I can all of a sudden see the bottom, that's where I'm going to stop it, and then you'll just record that measurement in centimeters. So now you know, SecuTube, how to measure transparency. So next up is phosphorus. And like I said, we have this phosphorus test kit here. So to measure phosphorus, first what you want to do, you're going to have 2 of these sample tubes. And the first one, you want to put clean water in from distilled water that you bring with, or in this case, the phosphorus test kit comes with some water to do the base sample. So I'm going to take this and pour it into, oops, it's not open. Pour it into the first tube. And for this, I mean, the SecuTube is pretty easy, but when you get into the phosphorus and to the E. coli sampling, again, just don't worry about remembering everything, because this is really just familiarize you with the process, because I think there can be a number of steps involved, and it might be hard to remember, like which line do I fill it up to, and what step goes first. So pay attention as much as you can, but don't worry about every single detail. So this one's to fill it up to the top line. For this purpose, I'm going to say this is close enough, but you want to get it, right at that line. And then I have this black box, and I put the first kind of clean sample on the left-hand side, which is our comparison sample. Put this water away. And then I've got this little jar here, and I want to take a sample actually from the stream and fill that up into this jar. So this is the sample we're actually testing. So we put the water in here, and then we have all of these little packets that are going to change the color of the water based on the concentration of phosphorus in the water. So you take one packet out. I'm not going to do it because we can save the packets. You take one packet out, you pour it into this jar, put a little stopper in, shake it up, and then you wait for 8 minutes while the solution is dissolved in that water. So just kind of set it aside for now. Clean up some of your other stuff. Move this aside. Great, great. And look at that, it's been 8 minutes. So now we take our second tube and we pour this sample up to the same line as our first tube. And we place it in the second spot of this box. And the cool thing is that we have this color wheel. So if there's phosphorus present in the sample, it'll change to a bluish color. If not, it'll stay clear. So we put this wheel inside the box, is it the right way? Close it, and then we look to see when the 2 colors match. In this case, since both of them are clear samples, there will not be a blue presence, and so we're looking at 2 clear colors to match it. And when you look at what the number is with 2 clear colors, it's 0, which means there is no phosphorus present in this. If the sample had a lot of phosphorus in it, it would be a blue color, and we would want to match the test sample with that blue color, and then we may get a reading of 30. So that is phosphorus in a nutshell. Now, for my favorite one, we're going to talk about E. coli. So, as Kenzie mentioned during the introduction, the 2 streams that we're looking at are both impaired for high levels of E. coli that are above the health standard. But when some of the agencies have done DNA testing on these samples, they have not been able to find a source of the E. coli. So it remains a mystery. Why are the E. coli levels high kind of throughout the year and really at uniform counts? And this is actually a regional pattern for Southeast Minnesota, where the majority of the streams are actually impaired for E. coli, and yet we're not really sure what the source is. So part of our goal with this monitoring program is to help figure out where is this E. coli coming from and shed some light on this mystery. So to do the E. coli sampling, this is a little bit more involved. And again, your team leads will have all of the equipment with them, so don't worry too much about that part. But the sampling sheet that you're going to use to take the sample of E. coli, it has to be refrigerated. So you're going to want to have, or your team lead is going to want to have a cooler filled with ice, and you're going to store the sample sheets in this cooler until they're ready to be used. But before we do that, we need to have sterile equipment. So 10 parts water, 1 part chlorine. You're going to rinse out your bucket, make sure that it's clean, and then you want to do 3 rinses with just this distilled water before your bucket is ready to go. And then you're going to retake that sample by lowering the bucket into the water, pulling it back up with a new fresh sample that is not contaminated with anything else. And while you do this, you're going to want to put some gloves on. And you may actually want to put gloves on earlier on in the process. Part of the reason that you want these gloves is that if the water is impaired for E. coli, as we understand these streams to be, you don't want to take the chance that there would be any health risks if you're handling the water and exposed to it. So it's better to be safe than sorry. So again, we'll provide all this information for you in writing. So you're going to collect the fresh sample after you kind of sterilized the bucket, cleaned it out, washed it out. You've got your gloves on. All right, we're good to go. So this is it's called 3M Petrofilm, and it's an E. coli count plate. So this is what it looks like. There's a little pink circle in the middle. So I set my count plate down, and then I want to draw a 1 millimeter sample from the newly collected water sample. So we will provide you with sterilized pipettes, and you'll want to use a different pipette or a new and fresh pipette every time you take a sample. For today, I'm just going to use this syringe, but in the future, you'll want to open a fresh pipette for each new sample. So now I have my 1 milliliter sample, and I'm going to peel this plastic cover back, not all the way off, just back. And as evenly as possible, I am going to place this sample of water onto the circle. Great. So the sample is there. Now I'm going to let this go very carefully, and you can maybe see that the water is darkening it. And then I have this plastic disc, which I'm going to match up with the circle. And I'm just going to press down. And what that does is it kind of seals it a little bit, but it also helps to distribute the water. So perfect. Now, any E. coli that is present in our sample is ready to grow on this plate. After you've written the information on the sample, you're going to put it in a plastic bag like this, and you're going to put it back in the cooler because it needs to stay cold until it goes into the incubator, which is the next step. Then, since there are about 25 of those sample plates in this bag, what you want to do to keep this fresh is just kind of fold it over, put a little piece of tape on it as such, and put this back in the cooler. We just did 1 sample to show you what it's all about, but when you're in the field and you're at a sampling site, you're actually going to want to do 3 of those. So the first one, you're going to use a 1 milliliter water sample that is from your distilled water that you bring with you from the grocery store. You know, just get a gallon jug of that. So this is for quality control to make sure that we're accurately counting the E. coli colonies. So you have 1 sample that is distilled water. You're not expecting any growth in that. And then you have your sample of the actual water that you're testing, and then you have a duplicate sample of that. So when you put all 3 into the incubator, you're going to want to see consistent growth from the duplicate sample and the original sample, and ideally no growth from the distilled water. So you'll be looking at taking 3 samples for each location. And so we'll be taking these samples to the incubator, and they do need to stay in a cooler for the duration of your sampling time. Typically, 2 to 3 hours, if we can get them into the incubator within that time period, is preferred, but they cannot go beyond 24 hours before getting into the incubator. So your team lead will drop off your samples at the lab. They'll go into incubation for 48 hours, and then we will be able to count the number of colonies of E. coli on that sample. And 1.26 colonies per milliliter is the standard for E. coli, or above the standard for E. coli. So basically, if you see more than 1 colony of E. coli or more than 1 blue dot on your sample, that is above the standard for E. coli in a body of water. So you don't really want anything to show up if it's an indication of healthy water. So we have a couple different options. Since we're working with the lab, we could have just the one team lead actually do the counts. And that might be logistically the easiest because she'll be in the lab and have access to it. So when that 48-hour time period is done, she may be able to just do those counts. But I think if other teams are really interested in counting their samples themselves, there's no reason we can't get those samples back to the team so that they are able to do their own counting, especially if they're interested in participating in that way. So we can kind of go with each team's preference, whether they want to do the counts themselves or not. The final piece, before we get to some of the just kind of logistics and structure of the monitoring, is DNA testing. So the E. coli counts are going to be really important to determine where we want to take samples to do DNA testing. So for example, if we're finding that at one of our sampling sites we have really low counts of E. coli, and then a little bit downstream from that we're getting higher counts of E. coli, that's going to be an indication that leads us to finding the source. So something's happening in between there that's changing the E. coli counts. And when that happens, we want to get a better understanding of why. So we're going to first just take a number of samples and do the incubation and find out what those counts are at various points on the creeks. Well, after those samples are taken, we will determine where is the best place to sample for DNA testing. And then Kenzie and I will actually go back and collect additional samples that we will send overnight refrigerated to a lab in Florida, unless we choose another location, but that's right now at least the best lab that we have in terms of being certified and actually capable of doing DNA testing. But it's fairly expensive, so we want to be very specific about which sites we take DNA samples or samples that will be tested for DNA, and then we'll send those to the lab and we should be able to get results about whether or not they can detect either bacteria that would be found in a human, in cattle, or in swine. And so we'll test for those 3 metrics and figure out, if it's showing up as present in any one of those 3. And that'll help us decide, maybe there's a leaky septic system upstream or farm runoff. We just don't know at this point. And there's a lot of mysteries that still have to be solved. But that really is the gist of what we're going to do here. I hope that I have helped you guys all get familiar with the equipment that we're using. And then just a couple of other kind of notes to keep in mind. We do have the website set up for our water monitoring program, and that is where you will submit all your information. So again, you'll have one of these sampling sheets that you actually take out with you to record all the information. And then the team lead will go online and actually submit it through an online form so we can track all of the data in one place. Kind of relying on the team leads to be responsible for the equipment and then to have some consistency. So ideally we want people to go out in 1 week interval. And then it's really important to know what are the conditions right after a rain event. So we're hoping that in addition to those weekly intervals, if there is rain event, that there's enough flexibility that we can also have the teams go out right after that so that we can look at conditions and how they change after a big rain event. We're hoping that we can get probably 5 sites on Bullard Creek, which is a little bit smaller, and then more like 10 sites on Hay Creek, which is a little bigger. So that'll be 5 sites per team. If each group has 5 sites, ideally you would go to all 5 sites in one day. So it'll be a couple hour commitment to go to all 5 sites, and or all 3 sites if that's what it ends up being. But yes, it'll be multiple sites in one day on weekly intervals. So some of the criteria for how we will choose them is, and I may have mentioned this in the very beginning, but if there is a tile outlet coming into the stream, we want to look at conditions upstream and downstream of that to see how that changes water quality, or if it changes water quality. If there has been a project implemented close to the stream that's designed to improve water quality, like perennial vegetation or shoreline restoration, we want to look again above and below that site so we can see how water quality may be improved. And then it'll also be based on public access. So public access is kind of like our first go-to. We know we can access that site because it's a road or a bridge, but working with landowners, we're hoping to also fill in those remaining sites based on that other criteria. And as we collect this information, so let's say we find really high counts of E. coli in one specific spot, really low counts in another spot. We might want to add on a sampling site or even remove a separate sampling site, or we're just getting no interesting information, to play that detective role and start figuring out or kind of narrowing our focus in terms of where do we think this pollution is coming from, and how can we work towards refining our strategy to collect better data that's going to help us find that source of pollution. From here, we're going to be reaching out to the team leads to actually get the teams together and have their first start date. So I'll be meeting with those team leads out in the field so that they can get going with this, and each team will kind of come up with a day of the week that works best for them, so that we can, make sure we can all move forward with this successfully and have a great project. But it's exciting. It's fun to learn more about our local bodies of water, and I'm excited, so I hope you all are too, and thank you for listening.